Good morning, everybody. Sorry I'm not able to be there with you today. I'm still in the process of kind of figuring out how long I need to be gone for and what needs to happen and all that sort of stuff. So here's your video for today, kind of outlining the lesson a little bit. And because I don't know who you're going to get for a supply today, so make sure you watch this video on top of whatever you do in class today just to make sure you're comfortable. First things first, we are starting a new unit as you had your test yesterday. I posted a question on Google Classroom asking you how your test went, so I'd love to hear from you guys on how you felt you did. If I'm going to be off for a while, I'm going to ask that your tests get mailed home to me so that I can mark them, and then I'll have a better idea of how you guys did. Alrighty, so the very last unit that we're going into, yes, I said the last unit we're going into, is Unit 6. It's a long one because we're mixing similar triangles and trigonometry together. Nice part is it is fairly easy. A lot of students like this. They find it pretty straightforward because there's a very easy method and process to follow. So you'll be handed out this package today. The first and second page, front and back, are your unit plans. Okay, so don't forget to go through the dates, look at what we're covering, and then also do the homework assigned, especially if it says the textbook homework. So for today in particular, you have textbook homework page 378 to 379 and 385 to 387. As well, you also have worksheets. It doesn't say it here, but in this package, you'll see at the end there are worksheets. So let's get started with the lesson. Today's lesson's pretty easy. Most of you are probably somewhat familiar with it. I've already filled out all the answers and stuff, and basically this video is just going to be me kind of summarizing and going through important things. I'll take pictures of the notes, so don't worry about trying to listen and write at the same time. I want you just to listen to the video, and then afterwards you can open up the pictures and copy out anything that you think you might have missed. So this is 7.1, 7.2 in the textbook. The first thing is looking at similar triangles. So there's a difference between congruent shapes and similar shapes. So with congruent shapes, they're exactly the same. So all sides are equal, all angles are equal. But with similar shapes, all corresponding sides are proportional and all the angles are equal. So it's important to note there that the angles are all equal, but the sides are going to be proportional to one another. And I'll tell you what I mean by that. So if we look down here a little bit more to like the proofs of kind of how we prove if something's congruent versus if we prove if something's similar, over here you'll see that if we have a triangle, two different triangles, the sides are all exactly the same, okay? So AB is equal to XY, AC is equal to XZ, BC is equal to YZ. So all three sides are all equal to each other and all angles are equal to each other. Where with similar shapes, we're looking at if they're in proportion to each other, which means we're looking at their ratio, which is why we put them in kind of a fraction form. So the way we do that is one triangle goes completely on the top, okay? So triangle ABC is on the top, triangle XYZ is on the bottom, and then the corresponding sides get matched up together, okay? So if we were looking at these two triangles, this side AB corresponds to this side XY, which is why we have AB on top and XY, and that's why they're together, okay? Because they're corresponding sides. So there's three different ways we can look at if we have similar shapes. The first one is if all sides are proportional, okay? So if all sides are proportional, then we have similar shapes. If we have a side in proportion, an angle that's equal, and a side that's in proportion, then we also have similar shapes. Or if we also have all three angles equal to each other. The reason why it says here only angle or two angles is because if we have two angles, then we can automatically find out the third angle, right? 180 minus the first angle minus the second angle will give you that third angle. So even if we're only given two angles, we can still find the third angle and figure out if all three angles are equal to each other. So let's look at the first example. So identify a pair of similar triangles and then explain why they are similar. So the very important thing to notice here is that the triangles are not in the same, they're the same shape, but they're not in the same placement, okay? So you have to be careful and look to make sure that you're comparing the correct sides together. So you'll notice AC is my longest side, so it's going to correspond to DF, which is my longest side over here. BC is my smallest side that I've highlighted in yellow, and my smallest side on this triangle is DE. And then I've got my oranges, which are my mediums, okay? So you have to make sure that you're matching up the correct sides in order to make this work, okay? In order to see the proper proportions. So then we actually have to set up our ratios, okay? So remember, all one triangle goes on top, all the other triangle goes on the bottom, and then we have to pair them up based on the sides that they correspond to. So AC, which is my longest side, goes on top, and DF goes on the bottom. It doesn't actually matter what order, as long as all of one triangle is on the bottom and all of one triangle is on the top. Because you'll see what happens is when I set all that up, and then I actually plug in my values, 20 divided by 10 gives me 2. 6 divided by 3 gives me 2. 16 divided by 8 gives me 2. Therefore, these are similar shapes because we have side, side, side. Okay, we weren't given any angles here, so we had to look at the three sides and see if they were in proportion to each other. So they are in proportion to each other by a factor of 2. Okay, so we would say that triangle ABC is similar to triangle DEF because of side, 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 and a proportion of 2. All right, so two main things there, like I said, making sure that you're matching up the correct sides with each other and taking notice if the shape has been, you know, turned or moved around, and then also setting up your ratios properly. Everything else should be pretty easy because you're literally just plugging in. You're looking at side AC, which goes from A to C, and it's 20. So you plug in 20. DF, go to D to F is 10, okay? And then you're just simplifying your fractions. Alrighty, so if we go on to the back here, identify a pair of similar triangles and explain why they are similar. So in this one, we actually have two triangles in one. So if you notice, the first triangle is the smaller one, A, B, C, okay? That shows the person. But then we have a bigger triangle, A, D, E. So they share this point in common. They share angle A. Therefore, angle A is obviously equal in both triangles. We've got triangle ABC, and we've got triangle ADE. So then we're also going to look at the fact that angle B and angle D are equal to each other because they've both been marked with the 90-degree symbol, okay? So both of those angles are equal to each other, which is 90. So therefore, we know that angle C must equal angle E because of the fact that we simply know the two other angles, right? So 180 minus angle A minus angle B will then give you angle C. Okay, and we know that angle A is equal to each other. We know that angle B and D are equal to each other. So therefore, what's going to be left over is going to be the same. So we have similar triangles here. Triangle ABC is similar to ADE because of angle, angle, angle. Here is another example where we share an angle. So if you notice here, the angles that shared is the angle E, so those are the same. Then angle A and angle C are the same because they share the same identification mark, and that's telling you that they're the same measure of angle. And therefore, we must know that angle B is going to be the same as angle D. And so we have, once again, similar triangles due to angle, angle, angle. And the reason why you know these are similar and not congruent is because clearly you can see they're different sizes, right? So congruent triangles also have all three angles equal, but they're the same size. And those are clearly not the same size. And these triangles are clearly not the same size. And so that's how we know that they're actually similar and not congruent. So now looking on this side of the page, this is actually the same example that was just repeated. And that's kind of stuff that we've already talked about. Over here, you'll notice in question 1 here, given the following similar triangles, I actually changed the shape, not the shape, but the placement of this triangle so that it would match up with this one, so that I could clearly see which sides corresponded to each other, okay? So that all I did was I just turned this triangle around so that it was like this, so that the 90-degree angle was there and the 90-degree angle was there, and my hypotenuse were on the same side. So then that way I know my sides very easily correspond to one another, okay? Determine the length of the missing side. So here, it's not actually asking you to prove that they're similar triangles. They're telling you that they're similar triangles. They're telling you that you've been given similar triangles. So now, because you know they're similar, we can find the missing side based on our proportions. So the missing side is EF, okay, which corresponds with BC. So I know I have to for sure use that proportion. So I set up EF over BC. And then over here, I'm going to use what else has been given to me. Well, 20 has been given me for DE. So DE goes on top because it's got to go on top because EF went on top as well. And then I also got to correspond that with the correct side, and that correct side is AB. I fill in what I know. DE is 20, so I plugged that in. AB is 1, so I plugged that in. BC is 3, and the missing side is X. And all you simply have to do is cross multiply, and you get the answer of X equals 60. It asks you then to determine the scale factor, so it's asking you how these triangles are in proportion to one another. And you'll notice that when you actually plug in all your values, because now we have 60 equals X, right? We get 20 equals 20. So our scale factor in this case is 20. So this triangle is 20 times bigger than this one. We've taken this triangle, we've multiplied it by 20, and we've gotten this much bigger triangle. Even though it doesn't really look like that on paper, but we know that that's the case here. And then it says compare the two areas of the triangles. So you're simply just taking the areas, right? Base times height divided by 2, filling in what you know and finding the areas there. Finally, on the back, our last two examples are more of word problems. So to measure the height of the pole, James stood 8 steps from the pole. Okay, so James stood 8 steps from the pole. Here's the pole. Here's James. He's at 8 steps away. And he noticed that his shadow was 9 steps long. There's his shadow. So his shadow was 9 steps long. And he knows that he's about 12 steps tall. Okay, so he's 12 tall. What is the height of the pole? So they want to know this length. Well, I know this total because I've got 9 here, I've got 8 here. So the entire length of this part of my triangle is 17. So once again, going back to the similar question we had earlier, we have 2 triangles in one here. Okay, we've got A, B, C, and then we've got A, D, E, the bigger one. So they share angle A in common, but I want to look at the sides because of the fact that I'm missing a side, okay? So I actually drew them separate here just so visually I could see it a little easier, and I encourage you to do the same, okay? So you can easily see that the smaller triangle there is only 9 on the bottom and 12 along the side, 9 and 12. And then your big triangle, the whole length is 17, and this is the side that we're trying to find because we're trying to find the height of that pole. So we set up our proportions the way we did before. AC corresponds to AE. BC corresponds to DE. Okay, making sure the same triangles on top and the same triangles on the bottom. Fill in what you know. We're going to cross multiply, so we get 9x equals 12 times 17, and we solve for x. Okay, so the height of that pole is 22.67 steps, okay, because they're talking in steps here. Finally, down here, we're looking at a word problem once again. Okay, we're looking to find the distance of the river because we want to know if he can actually swim across it. Okay, so we have angle B here in common. And we're looking at the sides that are proportional to each other. Okay, so AP is proportional to TC. Then we've got PB is proportional to BC. Okay, same triangle on the bottom, same triangle on the top. We plug in what we know. We cross multiply, so 9.3 times TC, 8.4 times 24. Okay, and then we solve for TC. So in this case, he cannot cross the river because we're told that he can only swim a maximum of 20 meters. And we find that the river is 21.68 meters wide. So he can't actually cross it. Okay, so hopefully that gives you a little bit more of an overview. Like I said, you've got some worksheets here of additional homework on top of your textbook work. Basically, you don't have to do all these questions, but it would be a great idea. And make sure you mark off which ones you have done, because when it comes time to review for the test and exam, you should be doing any of the ones that you haven't done already, right, as part of your review. So if you do a question, maybe mark it with an X or something like that. Feel free to still be able to contact me through email and through Google Classroom. You can take a picture of the question that you're having issue with, whether it's on the worksheet or the textbook, and then send me it through email or even post on this just below the video, and I'll get back to you with a solution. Alrighty guys, hang in there and keep up to date and help each other out, please, especially if somebody's absent. Help catch people up and let them know what's going on. Alrighty, thanks very much guys, take care, bye.